One of the topics in college algebra that really gives people a hard time is solving absolute value inequalities. So I want to do this on absolute value inequalities and the equations, because you really can't do the inequalities unless you can do the equations. And I want to make sure everybody gets an idea of being able to see this so that they can tell how it works. There are three possible situations when you're dealing with absolute value of something. You could say that the absolute value of x is equal to some number, and I'm going to let C just represent some constant number. The absolute value of x could be less than C, or the absolute value of x could be greater than C. Now, in the inequalities, it could include greater than or equal to, or less than or equal to. That's not really going to have any effect whatsoever on how you do those problems. It's going to be based on the less than or the greater than part. If we had the absolute value of x was equal to 5, how many numbers have an absolute value that's equal to 5? Now remember, the absolute value is the distance from 0. This literally means that the distance from x to 0 is 5 units. So if you look at the number line, here's 0. If we go 5 units this way, we're going to be at 5, of course. Now, this is a non-directional distance, so we could also go 5 units in the other direction and look at -5. And sure enough, the absolute value of 5 is 5. And also the absolute value of -5 is 5. So x can be 5 here, or x could be -5. So the solution set is the set of x's such that x is equal to 5 or x is equal to -5. We don't need an inequality to describe this because it's just these two exact points. So if we had something like the absolute value of 2x minus 7 is equal to 18, then this 2x minus 7 could equal 18, because then you'd have the absolute value of 18, which is of course 18, or 2x minus 7 could be -18, because the absolute value of -18 would still equal 18. So we have to solve both of these. So I'm going to add 7 to both sides here. 2x is 25, divided by 2. The x would be, well, I could just leave this as 25 over 2. I could put 12.5. If I had to put it on a number line, I'd like to change it to 12.5. But in college algebra, we usually just leave stuff as an improper fraction. My steps over here are going to be exactly the same. I'm going to add 7, but adding 7 to a negative number is not going to give me the opposite that it did here. So this is going to be 2x equals a -18 and a +7 would be -11. Divide by 2. x is going to equal a negative 11 halves. Sometimes people will think that they could just work the positive part and then just get the opposite of that. You can see that that doesn't necessarily work. So the solution set is the set of all values x such that x is 25 over 2, or x is a negative 11 halves. With a less than. Oh, I want to point out one other thing first. What if I had the absolute value of 3x minus 4 is equal to negative 6? Can I set this equal to negative 6 and equal to positive 6? What kind of an absolute value is equal to a negative number? I hope your reaction is no absolute value is going to equal negative number. Absolute value is always positive. This is going to have no solution. Hopefully you would catch that right off the bat. The only other possible way to catch it would be, of course, once you get your answers, to go back and plug them in. So if you don't check your answers, you better make sure that you catch something like this right off the bat. Now, you have to, before you change it to equals the positive and negative, you have to have just the absolute value over here. I could conceivably have had negative 2 times the absolute value of 3x minus 4 plus 5 equals negative 7. And my first reaction would be, uh-oh, there's a negative over there. But it might, or it might not stay negative. I have to get it in this form. The absolute value of something is equal to something. I've got to get the absolute value by itself. So it's multiplied by negative 2, 5 added to that. I need to get rid of the 5 first. So I've got negative 2 times the absolute value of 3x minus 4. That cancels, equals negative 12. Then I have to divide out the negative 2 because I got to get it down to just the absolute value. So I've got the absolute value of 3x minus 4 equals, this is actually turning out to be a positive 6. So this one is workable. So I'd say, okay, well then 3x minus 4 is equal to 6, or 3x minus 4 is equal to negative 6. Add 4 to both sides. 3x equals 10, divide by 3. So one answer is going to be 10/3. Here I'll add 4 again. 3x equals negative 2, divide by 3. X is a negative 2/3. Now notice this works. If I go back down here, if I go back and plug this in, I'm going to try the negative 2/3. So the negative 2 times the absolute value of 3 times negative 2/3 minus 4 plus 5 equals, I hope, negative 7. Work, when you're checking, go through absolute value, go through the order of operations, sorry. Order of operations always says do grouping symbols first. In this case, these absolute value brackets are also kind of doubling as grouping symbols. And within the grouping symbols, you also follow order of operations. So in here, I need to multiply this and then subtract that. And then I'm going to multiply by the negative 2, and then I'm going to add the 5. So I'm going to shortcut a little of this. 3 times a negative 2/3 would be a negative 2. Negative 2 minus 4 is negative 6. The absolute value of negative 6 is positive 6. So this is negative 2 times 6 plus 5 equals negative 7. Negative 2 times 6 is negative 12. Plus 5 is equal to negative 7. So this does check. So here's my 2 answers. Okay, so moving on, let's look at the less thans. If I have the absolute value of x is less than 6, that means x is any of the numbers which are less than 6 units away from 0. Here's 0. 6 units to the right is positive 6. 6 units to the left is negative 6. If x is any of the numbers which are less than 6 units away from 0, then the solution set would be any of the numbers between 0 and 6, not including the 6, because 6 is not less than 6 units away. And going to the left, it could be any number between 0 and negative 6. It can be 0. 0 is less than 6 units from 0. So basically anything in here. So notice that this is actually one interval. One interval with 2 endpoints, so that if the absolute value of x is less than 6, that means that x has to be smaller than 6 and larger than negative 6. So x is any number between negative 6 and 6. Or if we put it in interval notation, we just put parentheses, because we're not including it, don't have the equals, parentheses, negative 6 to 6. So if we had a more complicated problem, absolute value of 5x plus 2 is less than or equal to 7. So 5x plus 2 would have to be between 7 and negative 7. The 5x plus 2 has to be less than 7 units away from 0. So the 5x plus 2 is any number that falls between negative 7 and positive 7. In this case, that's going to have brackets, but this is the 5x plus 2, not the x. So we need to figure out what the x itself would be. So that means if we rewrite this as an inequality, negative 7 is less than or equal to 5x plus 2 is less than or equal to 7. Literally means 5x plus 2 has to be between negative 7 and 7. It has to be smaller than 7. But if negative 7 is smaller than 5x plus 2, then 5x plus 2 is bigger than negative 7, right? So it has to be larger or to the right of -7, and to the left of +7. And when we write this as one inequality, that means it has to have both of these qualities at the same time. If you write this as two separate problems, then you're saying it could be less than 7 or it could be greater than -7, and that would be any number. Any number is either smaller than 7, that would go all the way down to -infinity, or bigger than -7, that would go all the way to +infinity. So this would be every single number and some of them twice. It has to be written as one interval. As one interval, it means it has to have both of these characteristics at the same time. So if it's to the right of -7, but to the left of +7, it's going to be right in here. Now to solve, this is called a compound inequality. Like a compound word, it's got two different inequalities combined together. So to solve this, the name of the game is to get x by itself in the middle. Do not break this up into two problems. To get the x by itself, we're going to subtract 2, right? We have to do it at both ends. Heard of burning your candle at both ends? In this case, that's a good idea. So this is -9 less than or equal to 5x, because those canceled, is less than or equal to 5. And we divide by 5, divide by 5, divide by 5. -9/5 is less than or equal to x, is less than or equal to 1. So on a number line, this would be anything from -5/2 up to 1 in between, and including the ends. So we use a squared off bracket. Interval notation, just write it without the line. Bracket -9/2 to 1 bracket. One more possible condition that we could run into, and that would be where the absolute value of x is bigger than some number. This means x is more than c units from 0. Okay, so here's 0. If this were, say, the absolute value of x is greater than 3. The numbers that are more than 3 units from 3, or 3 units from 0, have to be the numbers up here or that's 3, here's -3, or the numbers down here. These numbers are more than 3 units away. All of these. Now, you can't write this as one interval because it's two separate intervals that don't touch. It cannot be both bigger than 3 and smaller than -3 because there isn't any such animal. So this has to be written as x is bigger than 3 or x is smaller than -3. Up here, that's the bigger than 3s, or down here, that's smaller than -3s. To write this in interval notation, we would actually do from -3 infinity up to -3, union 3 to infinity. Remember that the union means we're putting both of these together to make one answer. It's the combined intervals, not that they touch. It's not saying they cross. It says it takes both of these to make up the answer. So if we had, let's switch things up. 6 minus 4x plus 5 is greater than or equal to -3. Okay, this is a red flag, but it also means that we got to double check and make sure the absolute value is by itself. It's not. So before we do anything else, we got to move this 5 to the other side. Just subtract it the same way you always would. So I've got the absolute value of 6 minus 4x is greater than, well, that didn't work out very well, -8. In this case, if it's saying the absolute value has to be bigger than -8, since the absolute value is going to be a positive numbers, and since all positive numbers are bigger than -8 or negative anything else, then our answer is all real numbers. It would be the set of x such that x is a real number, or the graph would be all numbers, or the way we write interval, all real numbers in interval notation is we say from -infinity to infinity. And of course, you always use parentheses on infinities. Okay, so that was an accident, but it was a good accident. So what if we just had the absolute value of 2x plus 3 is greater than or equal to 4? So it's got to be bigger than 4. 2x plus 3 is greater than or equal to 4. Notice that the positive one always looks exactly the same thing as this, just without even the brackets. That's because if 2x plus 3 is positive, then the absolute value doesn't do anything. So the positive part is going to look exactly like this without the absolute value. The negative, when you put 2x plus 3 and you put the -4, is going to have the other sign. So 2x plus 3 is bigger than or equal to +4 or smaller than or equal to -4. So I'm just going to subtract my 3 from both sides and divide by 2 both sides. So one part of the answer is x has to be greater than or equal to 1/2. Or less than or equal to 7/2. Don't think you're always going to get one positive and one negative answer over here. That's not true. The graph of this would be that it's greater than or equal to +1/2 or less than or equal to, I'm going to square them off, the -7/2. And the interval notation would be from -infinity to -7/2. That gets a bracket. That always gets parentheses. Union 1/2 to +infinity. So the rules you go by. If you have the absolute value is equal to something, you say x is equal to c, or x is equal to -c, assuming that c is greater than 0. If we've got the absolute value is less than some number, it has to be in between the positive and negative to be less than that many units from 0. So it's going to be stuck in between -c and +c. And if we've got the absolute value is greater than some number, then that means it has to be in the two separate ends. So x is greater than c, or x is less than -c. You have to set these up to start with correctly, or it's not even going to count. So that's it for absolute value. Those are all linear, but that's all we're going to deal with. So have fun. Talk to you later.